Okay, so today we're going over lesson 7-2. We're going to be taking what we learned about proportions in our last lesson, and we're going to incorporate it into solving for polygons. So today's learning intention is I will learn how to identify and solve for similar polygons. If you need to pause to get this down, please do so. Similar is basically saying also polygons that are in proportion to each other. Polygons that may be different sizes but are in proportion, therefore they're similar. All right, so let's talk about similar polygons. In order for two polygons to be similar, they must have what I have here. One, corresponding angles must be congruent. Okay, so corresponding angles must be congruent or the same. So they might be different sizes, but the angles will be the same. And if the angles are the same, we know that the corresponding sides are proportional. Okay, so we're going to be using a scale factor to find those sides, and I'm just going to go ahead and make a note of that now. But we're going to learn about that here shortly. Okay, so moving on. Given ABCDE is similar to PQRST, find the following. And we're going to talk about this little guy right here just for a second. This is a symbol we're going to be using to show similar or proportion. Okay, so when you see that, that's what that's indicating. And we're going to go ahead and make some arc marks, and arc marks kind of help us keep our bearings in check from polygon to polygon. So looking at this, we know that A is in the same position as P. I'll give that one arc mark. We know that B is in the same position as Q. Whoops, I need to put my P still. And my B is in the same position as Q. My C, I'm going to do 3 arc marks, is in the same position as R. And my my D right here is in the same position as S. 1, 2, 3, 4, and I'm ready for 5 arc marks. My E, 1, 2, 3, 4, 5 is in the same position as T. 3, 4, and 5. Okay, so when we do this, that's going to help us come over here and solve these real easy. So the measure of angle A is congruent or the same. So A over here is the same as which one over here? P. P also has 1 arc mark. So if I look at the measure of angle B and I come over here, it's congruent to angle Q. And if I look at C, C is congruent to angle R. Now we're going to look at some segments. So right here I have segment AE. AE is right here. So which segment is congruent with this one? Now sometimes our polygons may not be sitting the same direction as each other. Sometimes this one might be shifted or sitting a little bit different. And that's why these arc marks will help us, because I know it's talking about the segment in between 1 arc mark and the 5 arc marks. So this one is also needs to be between the 1 arc mark and the 5 arc marks. So this is segment P over T. And then they're asking us about segment AB, which is here, between the 1 arc mark and the 2, and this one's also between the 1 and the 2, so this is PQ. And now we're going to try to find one of our own. So if I give you BC, let's see if we can try to find a segment that is congruent with BC. And it would be this one. Yes, QR. Okay, so now we are going to try to solve for X and Y. And we're going to do this, we're going to try to find a scale factor, and we're going to get in the habit of using big over little, okay? So the biggest polygon over the smallest polygon. And the way you do this is you find 2 segments that are in proportion that we also know. So we know that X is in proportion to 12, but we only have the value of this one. We don't have X, so we can't use those. And we know that this segment's in proportion to this one, but we don't have the value here. We do know that this one is in proportion to this one, and we have both values. And since we're doing big over little, we're going to do 32 over 20. Okay? Now, this can be simplified down, so we're going to go ahead and simplify this down. And we know that 2 can go into both. Is there anything greater than 2 that can go into both? Okay, we know that 4 can go into both. Okay, so is there anything greater than 4 that can go into both? So if we do this, 4 goes into 32 8 times, 4 goes into 25 times. And then you might check one last time to see if this can be simplified anymore. If not, this is your scale factor. And this is what you can use to solve for every single other segment. So let's go ahead and solve for x. We're going to use our scale factor, which is 8 over 5, and we're going to just set it up like this from the very start. 8 over 5, and we're going to go find x. And keep in mind, we're doing big over little, so keep this in mind, B over L, big over little every single time. Big over little, it has to stay that way. So let's go find x. X is over here, so is this on the big polygon or the little polygon? Okay, it's on the little one, so we're going to put x on the bottom because little is on the bottom. And then we're going to find what is in proportion to x. It is 12, and that's on the big polygon, which is on top. Okay, so you can either set this up kind of how we learned, which would be 8x equals 24, or you can simply cross multiply and then divide by the guy opposite the x. And you should get 7.5. Okay, so let's solve for y. We're going to use the same exact scale factor because we're using the same 2 polygons. So I'm going to set it up just like I did right away. 8 over 5 equals, and I'm going to go ahead and get my fraction bar out there. And this time I'm looking for y. Is y in the big polygon or the little polygon? It's over here in the big one. So we want big on top, so this y will go on top. And this is in proportion to what value over here? 18 on the little one, so that's what will go on the bottom. Okay, now we can set it up if you want the way we learned. 18 times 8 equals 5y, or we can simply cross multiply and divide by the guy opposite the y. So y should get you 28.8. Okay. Moving on, number 2. We have A, B, C, D. We have our similar sign or proportion sign to A prime, B prime, C prime, B prime. So we're going to go ahead and make our arc marks. We know that A is in the same position as A prime. We know that B is in the same position as B prime. We know that C is in the same position as C prime. And lastly, we have D is in the same position as D prime. 1, 2, 3, 4. There we go. Okay, so let's look over here. It's asking for a scale factor. Remember, we need to find 2 segments, and we're going to write big over little, okay, that are known that we can use. They have to be proportion, and they both have to have values. So if I look at this one as my big one, I do have a value here, and it's between 1 arc and 4. So let's go find the one between 1 arc and 4. It's over here, but this one doesn't have a value, so I can't use that. If I came over here, this one doesn't have a value. I can't use that one and this one. Let's try this one. This one has a 30, and the segment in proportion to it is this. They both have values, so I can use those. So I'm going to put my big one, which is 30, over the little one, which is 20. Okay, and I need to simplify this down. And by doing that, easily I can see I can just cross out these zeros. By doing that, that gives me 3 over 2. And then if you'd like to take this a step further, if you actually divided these out to get a decimal, it would be 1.5. Okay, so this is going to be our scale factor that we're going to use. Back in chapter 2, we talked about dilations, And if we wanted to take every value times this, we could also do that. Now, sometimes it won't come out as clean of answers, and so you don't always want to do that. A fraction should always get you a pretty clean answer. So it is another option. Okay, so let's solve for x. And right away, we're using our scale factor. I'm going to set it up right away like this. And big over little. So I'm looking for x. X is on, not the big one, the little one. So x is going to go down here. And what's in proportion with x? 21 on the big one. Okay, so now I'm going to cross multiply, and I'm going to divide by the guy opposite x. And this should give me 14. Okay, now I'm going to look at y, and I'm going to set them up right away, like with my scale factor equals and that. Do that first thing. Now I'm looking for y is on the big one. So that goes up top. And what's in proportion with y? It's this guy over here, which is the 8, on the little one, which goes below. So if I want to cross multiply and then divide by the guy opposite y, I will get 12. Okay, looking at w. Once again, setting it up just like I have been. Now I'm going to go find that w. Here's w. He's on the big one, so the w is going to go up top. What's in proportion with w on the little one? It's right over here. It's 10. It's going to go on the bottom. Okay, so now I can cross multiply these, divide by the guy opposite of w, and I will get 15. All right, number 3, let's look and see. They are sitting in the same positions. I don't see anything different, so we can tell that this is going to be one arc. 2, 1, 2, 3, and 1, 2, 3, 4 with this guy here. Okay, now I have my big polygon over here and my little polygon over here. So we need to remember, once again, big over little. So let's do a scale factor. Once again, we need to find 2 segments that both have values to get started. So if I look at my big one and I have 60, what's in proportion with my 60? It's z. I don't have the value of that, so I can't use those. Let's go try this one. 25 on my big one, and what's in proportion with 25? The one between 2 arcs and 3 arcs, that's this here, 10. I have 2 values. I can use that. So my big over my little is 25 over 10. Looking at these, I know they can be reduced. I know that 5 goes into both. So this would give me 5 over 2. 5 goes into 25 5 times, 5 goes into 10 2 times. I'll double check it, make sure it can't be reduced anymore. This is my scale factor. Once again, if you want to divide that out, take it one step further, it's 2.5. Okay, so let's set these up to find x. Just like we have been, the first thing I'm going to do is use my scale factor equals, set it up like that. Solving for x, I'm going to go hunt for x. It's in the little one, so it goes on the bottom. What's in proportion with x? Over here on the big one, it's 35. It'll go on top. I will cross multiply and divide by the guy opposite x, and I should get 14. Okay? Solving for y, setting it up just like I have been. Now y, I'm going to hunt. It's on the big one, so it goes up top. What's in proportion with y? It's this guy right here, the 8. Right? So now I can cross multiply and divide by the guy opposite y, and I should get 20. Let's see here. I'm going to add one more. I'm going to add z. And so I'm going to set it up just like I have been. 5 over 2 equals, and my mark. Okay? Z. Z in the big one or little one? Z is in the little one, so z goes on the bottom. Proportion to this guy, which goes on the top. So I will now cross multiply and divide by the guy opposite z, and I think you get 24. Okay, check my math, make sure I'm right. Could be wrong. Yep, 24. Okay, Let's look down at the bottom. It says, tell whether the polygons are always, sometimes, or never similar. Well, let's see. Two equilateral triangles. There is something we have learned about equilateral triangles, and it has to do with the angles. Trying to draw these, they're not perfect, but one thing that we learned about equilateral triangles is that every single angle, no matter what, is 60 degrees. Okay? So all of these angle measures will always be the same. If that's the case, then we know that these are always going to be similar. So this is always. All of these sides will be the same, but they may not be, this may not be the same as this, but they will be in proportion. Okay? Two isosceles triangles. So isosceles, we could have where we have isosceles, the angles may or may not be the same. We could have this and this and this and this and base angles, but there might be something else different. So these are going to be sometimes. They could be similar, but they may not always be similar. And then rhombuses. You could have two rhombuses with all congruent sides. Like these might all be congruent, and these sides might be congruent, but maybe the angles are not. But you could have two rhombuses with congruent angles. So this is also sometimes. There's just not enough information sometimes to know. Okay? All right, that's going to conclude today's lesson. Please, if you have any questions, don't feel free to ask, and good luck on your homework.